टाइम ट्रैवल विथ एनजीटी चैनल। आज हम डिफरेंशियल फॉर्म ऑफ गॉसिस लॉ का विकलन स्वरूप, गॉसिस लॉ इन प्रेजेंस ऑफ डाइलेक्ट्रिक की हाजिरी में, इन द प्रेजेंस ऑफ डाइलेक्ट्रिक गॉसिस का लॉ क्या है उसके बारे में चर्चा करेंगे। उसके पहले हम व्हाट इज डाइपोल मोमेंट, what is bounded surface charge density, what is polarization density, what is the relation of three-dimensional volumetric bounded charge density equal to negative divergence of polarization density, differential form of Gauss's law. Then we will discuss about Gauss's law in presence of dielectric. What is D? D is the displacement vector. ये सभी की चर्चा करेंगे। Okay, now you know that suppose this one is a neutral atom. For neutral atom, positive charge is coincide with the negative charge. Center of positive charge is coincide of the negative charge. So it is a neutral atom. When this type of neutral atom is kept under the effect of electric field, what will happen? Positive charge will be shifted towards the electric field. Negative charge will shifted opposite to that of the electric field. That produce dipole moment. So dipole moment P equal to charge multiplied by distance. D is the distance between positive charge and negative charge. Okay, and direction of dipole moment is from positive to negative, I mean opposite to that of the electric field. What is its unit? Coulomb into meter. Coulomb into meter. Okay, so this one is the dipole moment. So dipole moment produced per unit volume, it is called polarization density. Dipole moment produced per unit volume, it is called polarization density. So polarization density equal to number of dipole moment produced inside the material. P again coulomb into meter. dV means volume, meter cube. Again, what is the dimension of polarization or polarization density or electrical polarization density? It is coulomb into meter square, because meter and meter cube here. So here coulomb into meter square. Now you consider any an insulator is kept under the effect of electric field. There produces positive charge, negative charge, positive charge, negative charge, and large number of dipole moments. Okay, so here these are the number of dipole moments like this. Okay, here is positive charge, here is a negative charge. Positive, negative, positive, negative, positive, negative will cancel to each other, but at the surface there will be charge. So this type of charge are bounded charge. In this type of charge density, it is called bounded surface charge density, I mean two-dimensional. What is density? Bounded surface charge density. Density equal to charge divided by area. So coulomb divided by meter square, I mean coulomb divided by meter square. So now you see, you compare equation number 2 and 3. In equation number 2 and 3, you can see both have same dimension. So in this way, we can say that the bounded surface charge density equal to polarization density. Clear? Now, here is the three type of charges. Linear charge Q equal to lambda into dl, where lambda is the line charge distributed along the line. Okay, so it is linear charge density. Q equal to line integral lambda into dl. It is one dimensional. Two dimensional, it is like this here. Okay, Q equal to sigma into A, just like that. So Q equal to surface integration sigma into ds. It is two dimensional surface charge density. Okay, so this one is called line charge, this one is called surface charge. This is called line charge density, this one is called surface charge density. Similarly, volumetric charge density, it is equal to rho. Okay, so charge distributed inside the volume is equal to volume rho into dV. Same equation, it is equation like this. Q equal to sigma into A, Q equal to rho into A, Q equal to lambda into L, just like that. From this equation we can derive all type of this equation. Okay, now again, what is our aim? We have already proved that two-dimensional bounded surface charge density equal to polarization density. Okay, now we will derive here three-dimensional bounded volumetric charge density is equal to negative divergence of polarization density, I mean minus delta dot P. We will also derive delta dot E equal to rho divided by epsilon 0. Means Gauss's, let me say, differential form of Gauss's law. Okay. Now you consider this one is a symmetrical material. I mean homogeneous material, dielectric material. What will happen if the material is non-homogeneous? That means positive charge, negative charge, or one dipole moment, another dipole moment, one dipole moment, another dipole moment does not coincide on each other. I mean some of the charge will be coming out from volume to the surface. So this one is the amount of charge. It is coming out from volume to the surface. Why it is so? Because dipole moment does not coincide on each other in inhomogeneous material. Suppose material is not a homogeneous but inhomogeneous, then what will happen? Some amount of charge will be coming out from volume to the surface. So this one is a volume charge and this one is the surface charge. Charge coming out from volume, so sign is negative. This one is a charge. Again this one is a charge. So according to conservation of charge, charge coming out from volume equal to charge on the surface. So this will be equal to, now what is the value of sigma b? This one is the surface charge. Surface charge density sigma b equal to capital P, I mean polarization. Again, you applied Gauss's divergence theorem. What is Gauss's divergence theorem? When you jump from surface to volume, you should take divergence of this vector. Divergence of this vector. Okay, it is called Gauss's divergence theorem. So again, minus volumetric integration rho b dv equal to, okay, this one is V, divergence of P into dv, equation number 6. Now volume is are same. Okay, that means volumetric bounded charge density is equal to negative divergence of polarization density. Here is a dot, delta dot capital P. Sign is negative. The sign is negative. Okay, this one is equation number 7. Now again let me say, flux passing through any surface is equal to EDS equal to charge enclosed by the surface divided by epsilon 0. But what is Q? Q equal to rho into dV. Volumetric integration rho into dV, like this. Okay, so let me say here. Okay, you jump from surface to volume, you should take divergence according to divergence theorem. So delta dot E instead of E, delta dot E instead of ds, you should write dV here. Okay, so you can jump from surface to volume equal to, like this, right hand side. Again volume is here, that is divergence delta dot E, but divergence of electric field equal to rho divided by epsilon 0. This is called differential form of Gauss's law. Okay, now again in the presence of dielectric material, we will see what will happen. So initially, suppose divergence of E equal to rho divided by epsilon 0. Suppose this one is the parallel plate capacitor. Here no medium is filled between two plate of capacitor. यहाँ हमने कोई भी डाइलेक्ट्रिक मटेरियल है बीच में अभी डाला नहीं है. ओके, सो डाइवर्जेंस ऑफ E इक्वल टू रो डिवाइडेड बाय एप्सिलॉन 0 विदाउट डाइलेक्ट्रिक, पॉजिटिव नेगेटिव two plates of capacitor here. There is no dielectric material. Now again what will happen if you place dielectric material between two plates of capacitor? Okay, that means what will happen? Rho will be splitted bounded surface charge density, bounded volume charge density plus free charge density. Here these are the bounded volume charge density and these are the free surface charge density. So rho B plus rho F, because dipole moment and polarization will take place inside this type of a dielectric material due to electric polarization. Okay, so again place the value of rho here. Divergence of E equal to rho B plus rho F divided by epsilon 0. But what is rho B? You know that bounded volumetric charge density equal to minus negative divergence of capital P, I mean polarization density. You take the value, this value, like this. Okay, divergence of E, minus sign will be there, this minus sign, delta dot P, it is delta dot P plus rho F, means free volumetric charge density divided by epsilon 0. Epsilon 0 come here equal to, like this. Okay, so now delta and delta are common, so delta dot is common, P plus epsilon 0 into E equal to rho F, I mean free volumetric charge density. So delta dot D equal to rho F. What is D? D equal to P plus epsilon 0 into E. So D is called displacement current. So D is called displacement current vector. It is superposition of epsilon 0 into E plus P vector. Epsilon 0 E into plus P vector. Now in figure you can show that capital P, I mean this vector is opposite to that of the electric field. Is opposite to that of electric field. But here it is a vectorial sum. Okay. So we have write like this. D equal to epsilon 0 into E plus P. Epsilon 0 permittivity of a free space. What is D? D equal to epsilon into E. You know here D is the displacement vector equal to epsilon 0 into E plus P. D equal to epsilon into E. Epsilon is the permittivity of a material. Okay, D is the displacement vector. E is the electric field. So this equation is called displacement vector related with electric field and polarization density. And you know that this equation is called as a Gauss's law in presence of dielectric material. Thank you.